I think you should do in the.
Sorry?
No, good. Sorry.
All right. Yeah. So, since about 9 years, I've been teaching Python. And like for a brief period of about 1 year, I worked with an institute called as Talent Sprint back in India, uh, as a Python and machine learning trainer. Okay, so as part of my job duties, I trained students of two colleges, basically called as BVRIT colleges, one in Hyderabad and one in Bhimvaram. Uh, and many of them are placed with product companies back in India itself, uh, such as Adobe, PayPal, Paytm, etc. Okay, and quite a few of them have already flown here into this country for their masters. All right. And after that, I also trained two batches of TCS new recruits, okay, on machine learning precisely, which means, I mean, I led the program of training their TCS employees on machine learning for about 1 week. Okay, that's my full-time training experience. After which, and before that and after that, I've been training in Python and machine learning. These days, most prominently, I'm doing Python with data engineering more than machine learning. So that is the intro about me. And someone by the name Verma has just joined in the session, and he's the one who actually made me start my Python training program at his institute back in India. The institute's name is called as Coding Sastra. Okay, so I started there, and he has joined us in the session today. So, any questions regarding my experience or anything so far?
No, it's great. Thanks to Mr. Verma Garu.
Varma
Uh,
garu,
yeah,
would you want
sure.
to give
Thank
us
you.
more intro of yourself?
Yeah, actually, yeah. So, Gautam for almost maybe 15 years or something. I didn't even know the exactly when we started, right? 2016, 2017, maybe. Yeah, I think 10 years probably around. Yeah, like, yeah, he's the trajectory of the success is, awesome actually when he started with me, and then he went to Talent Sprint and Infosys and all the companies, and where he also did a lot of training. And yeah, actually, I've been also like training at the same time when we started together. So I was doing a full stack and he was doing a Python. So yeah, so a huge experience. And and after the his Indian career, and he moved to US on H1B, and then he's working for Cisco, right? So yeah, definitely it's his success in the industry is awesome, and definitely all of you can learn a lot from him actually. So he
Sure.
yeah, thank you, Gautam, for the introduction of me also. Thank you.
Thank you, sir. Yeah.
Thank you.
All right. So that is about me. If you have more questions about me and my experience or anything like that, I will start with the introduction to the course. Okay. So, uh, this is planned to be a 2-day quick ramp up boot camp on Python, so that on the constructs or the building blocks of the language called as Python, so that right after these sessions, you should be able to implement what the ideas that you have and take your experience with programming and software further. Okay, so this is a quick ramp up on the language. So once we learn the language, we can, what do you call, communicate whatever we want to communicate with some person in real time. Why do we learn a natural language is, uh, the reason for learning a natural language or a language is to be able to communicate. So the natural language is the, what do you call, the bridging, I mean, the bridge between two individuals. If natural language is considered to be the bridge between two individuals, then programming languages are the bridges between an individual and a computer and a machine. Okay, so our target in these 2 days is to learn the language so that we can implement and do whatever we want with the language after these sessions. So that is the target. And why am I mentioning that we will be learning the programming constructs here more than programming itself? Is the programming actually means understanding the techniques or the logic behind, what do you call, getting things done. For example, let us take an example of a bag of elements. Okay, a bag. Let us say there is a bag that has about hundreds of elements in it. Now, in those hundreds of elements, you want to pick one particular element, right? That is called as searching for an element in a given collection of elements, or searching for an item in a given collection of items. Now, in how many ways the search can happen? Okay, there are many ways in which a search can happen. We will not be discussing the different ways in which searches can happen and the efficiencies of each particular search. Instead, we will be talking about the different language constructs that we have in getting the task done in the most simplest way possible. When we call it simplest way, simple for us to write code. How efficient is it? We are not bothered of today. Similarly, given a collection of numbers, let us say randomly you have generated a list of numbers. Now you want to sort them in an ascending order, right? We will be discussing the different methods available in doing that sort today. But we will not be discussing the different sorting techniques or the different ways in which one can implement the sort and the efficiencies behind. Those will not be part of the sessions. If you are interested in learning those algorithms as well, then Coursera has a free course developed by Segway, the guy who actually written the book, The Red Pad for Algorithms, uh, Richard or Robert Segway, if I'm not wrong. You can look into that course, and there you can learn the algorithmic techniques. But today we will be learning the constructs of Python. I mean, in these 2 days, we will be familiarizing ourselves with the constructs of Python. All right. Any questions there?
So can you give again the author name, please? That Coursera you said just
Robert
before.
Segway. Sedgwick. Sedgwick.
And what is the course name?
Algorithms.
Okay. Thank you.
No problem. Okay. He is the author of the book and he himself taught that class. Okay. Yeah.
Sure.
If no questions there, then let's just dive right in. So I wanted to start with what is Python, but even before what is Python, let us understand what is programming in the first place. So what do you guys think programming is?
A communication
Anybody?
between a simple language is a communication between from the human to system to system. It's kind of a language which can understand.
Beautiful. So basically, programming is nothing but telling something to a computer. Why do you want to tell something to a computer? Anybody? Because we want the computer to do that, to perform that. Okay, that is the basic idea. We want to tell a computer something so that it will be able to do that. So what does computers understand? Which language does a computer understand?
Binary?
Machine level?
Beautiful, binary, zeros and ones. How does a computer understand 0 and 1?
Some converter like interpreter or something which will change our text to the
So,
number.
right, whatever we write, it will get converted, that is there. But computer understands, so whatever we write is converted to zeros and ones, correct?
Hmm.
How does computer know what does zeros and ones mean?
It's like on or off, like a on or off position on the hard drive, right?
Beautiful. Right. Let us say we have 4 LEDs. Okay. Let us say we have 4 LEDs. Each LED can exhibit 2 states, either on or off. Am I correct?
Yeah.
Okay. Each LED can exhibit 2 states, on or off. Now, we are representing, or we are telling ourselves that if this LED is on, then we will call it 1. If the LED is off, then we will call it 0. So is the case. If it is on 0, I mean 1, and if it is off 0, on 1. Off 0, on 1. Off 0, on 1. Okay. That is our convention. We have decided that if an LED is nothing but a light emitting diode. Why are we thinking of an LED here? Because we know light, if the LED is on, then there is a light coming out of it. So which means we can understand if that particular device is turned on or not. Right. So this is our convention. Fine, very nice. Now, with these zeros and ones, how are we constructing the huge programs here?
I
Anybody?
I do bio research, so I think of it kind of like how DNA works. Like we only have 4 bases, but you get all kinds of expressions of genes out of those 4 bases. So it's like a lot of different on and off states combine into like I guess it's like letters combining into words kind of a thing.
Beautiful, perfect actually. But a small missing thing here is again it is our human convention that we are taking here. Okay, what we are doing, the next step of convention is the first LED we are marking it as 1, which means if this LED is in position 1, which means it is turned on, we are taking the number as 1. Okay, and the second LED we are marking as 2, third LED we are marking as 4, and fourth LED we are marking as 8. Okay, it's all power of 2. All right. Now, which means if the second LED is turned on, which is the state 1, which means that value we are considering it to be 2. If the third LED is on, then the value that we are considering that it is exhibiting is 4. Okay. Any questions so far?
No.
This is our conventions. We are saying, okay, if this LED is in on position, then if this LED is in on and all other LEDs are off, then we are considering the total value to be 8. If this LED is on and the other LEDs are off, then we are saying, okay, the value of this expression is 4. Okay, which means now let us take 0 for the first LED, 0 for second LED, 0 for third LED, and 0 for fourth LED. What is the value of the total expression? 0, 0, 0, 0.
It's a 0, right?
Right. Now, 0 for the first LED, the value for the first LED is 0, the value for second LED is 0, third LED is 0, and fourth LED is 1. Now, what is the value of this expression?
1.
Beautiful. The value for the first LED is 0, value for second LED is 0, the value for third LED is 1, and the value for fourth LED is 0. Now, what is the value of this expression?
2.
Right. Again, now 0, 0, 1, 1. Now, what is the value of the expression?
Adding like 2 and 1 together, 3.
Yes, 3. So, with these conventions, we are building numbers from 0 until 15. Why 15? 1, 1, 1, 1. When all LEDs are turned on, the total value, how much it is? 8 plus 4, 12 plus 2, 14 plus 1.
15. Okay.
This is how a computer understands, like when all the 4 LEDs are turned on, the computer knows, okay, the value is 15. The user is trying to tell me that 15 is the value that he is looking for. Any questions?
So you chose only 4 LEDs is because of the byte or something like that to
Yes. So this is the most fundamental computer, digital computer ever built. A 4-bit computer, which is nothing but a calculator.
Mhm.
And for the simplicity's sake, I have taken 4 bits.
4.
Each device can exhibit 2 states, and hence each device is called as 1 bit, either 0 or 1.
Okay.
Yes. Any more questions?
No.
All right. Now let us say I want to tell to a computer to add 2 plus 3, right? And in this stage, we are currently here. We don't know any other language. Okay, we know only zeros and ones. Now with zeros and ones and a 4-bit computer, can you guys tell me how is 2 represented in binary format in the 4-bit expression?
0, 0, 1, 0.
Beautiful. And how is 3 implemented
The next
or
one like
represented as?
0, 0, 1, 1.
Right. Okay. Now we want to add these 2 numbers. Okay. Now the simple addition rule, because addition is what we are doing here, is simple addition rule is 1 plus 0 is 1. Clear? Okay. 0 plus 0 is 0. That is also clear. Right? But just like in our regular numeric addition, we always perform addition operation from right to left fashion. Okay. So what we do is we first add 0 and 1, these 2 digits. 1 plus 0 is 1. Now we have 1 plus 1. Okay. In this case, we write 0 here and 1 here. Okay. Now we add 1 plus 0 plus 0. It is similar to 1 plus 0, which is nothing but 1.
Mhm.
Now, when you have a 4-bit computer, 8421, and when you have the value 0101, what is the decimal value of this binary number?
4 plus 1, 5.
Did we get the result?
Yeah.
Excuse me. So that is what that is happening. And that is how a computer can understand or can perform the instructions given to it by looking at zeros and ones. Here we are calling them as LEDs for our understanding, so that when it is turned on, we know that a light is being emitted through it. When it is turned off, we know that, or we can imagine that no light is coming out of it. In real scenario, it will not be an LED, but just a D, nothing but diode.
I have a question. Like, what is it physically that switches on or off on a computer?
Okay, the circuitry. That's what you're talking about, right?
Yeah, like I've heard it's like magnetic, or I think maybe, I don't know. But like I was wondering what's actually like switching on or off.
What is actually switching on or off? So when a power, let us say a diode is nothing but a device like this, right? Where you have an inflow of current and an outflow of current,
Okay.
right? So we have something called as gates, AND gate, OR gate, etc., etc., right? Now, the gates here they have some kind of material, some chemical is put where it decides like how whether to pass current through this diode or not. When current is passed through this diode, it exhibits it gets turned on and exhibits the number 1. I mean, representing the number 1.
Okay. Okay, so it's like so on would be like current going through, off would be current not
Right,
going through. Okay.
right, right. On means current going through, passing through. Off means no current is being passed through.
Cool. Thank you.
No problem. Any more questions, anybody? Now, when you understand this mathematics, programming is, I mean, which means using just zeros and ones, we can talk to a computer. Am I correct? With just zeros and ones, if we can talk to a computer, why do we need all this?
To do calculations.
Sorry, 1 second. One second. All right. Yeah, if we can work with zeros and ones, why do we need, what do you call, all other programming languages that we have now?
think it would be pretty hard to program everything in zeros and ones. So
Beautiful.
it just makes it easier.
Precisely. Since it is difficult for us to understand computer's language, we have come up with ways of talking to a computer in as human a language as possible, but build a machine inside the computer that could translate whatever we are giving it, whatever we are talking to the computer into the language understandable by the computer. Okay, so we are building black boxes in between, okay, where we talk to this black box in as natural language as possible. Okay, and this box, B box, okay, is what that will be converting this into zeros and ones or into the understandable language of a computer. Now, there are many such boxes existing in the universe. Like, to be frank, literally millions, right? But only a handful of them are really popular in the industry. The first language that came from zeros and ones is called as assembly language. Okay, the first language that came is called as assembly language. It is closest to zeros and ones than to humans. Okay. Now, after assembly language, we have developed other languages like COBOL, Fortran, etc. C, C++, C Sharp, then came Java, and even more recent one is Python. Any questions there? Which means Python programming language. When we talk about Python, we are talking about this black box that could convert whatever we write into the language understandable by a computer. Any questions? And if I'm not wrong, Python is so far the closest to human language. Python programming language is the language that is so far the closest to natural human language available that we have in the market as of now. Any questions? And that is the result of, and that is the reason behind all its popularity. So what if the language is easy?
That's the point.
Sorry?
I said that's the point, I think.
Yeah, so what if the language is easy for us? It is the language is easy for us, but for the computer it is actually, what do you call, a little slower compared to Java or other more closer to computer programming language. It is easy, Python is easy for sure, but slower compared to these other programming languages. Then why did Python gain its popularity that it has gained?
So as far as I know, I mean, in terms of the writing, the only thing that people need to care about is the intent, but all other ones are like much easier. You can write it like as a natural language talking type of scenario instead of using like syntaxes, and there is a lot of minimized in the Python.
Yeah,
So
boilerplate code is a good example, good point.
mm,
There are no so many formalities like in Java or other programming languages. Python is much more easier to write. That has been covered. But the ease is coming at a cost of speed of execution.
right,
But still, Python is currently, I think, the most popular programming language on the planet.
right.
Why?
Because of its intercompatibility with other languages. Because so for faster ones we use C++. But Python can be easily uh, communicated with other libraries, which is made with other languages. Is that?
That is a good point.
Yeah,
But
one
that is a
point.
good point for sure. Remind me on this point. We will talk about this a little later. Okay.
Something like
But the
machine
main,
language, also
sorry,
one of the thing, data science, machine language, web development, like various platforms, right? That is what I was wondering.
like
It's a,
why did they adapt Python first?
the language, easy as you mentioned that you already told. Um,
Yeah, we
And that
around.
is that again, that is the reason they were
correct, correct.
okay to
Many are there.
compromise.
Correct.
Yeah, there is, I mean, they were okay to compromise on the a little bit of speed compared
Cross-platform
to the
support.
ease. Sorry.
It's a I because when I did this cloud and everything, right? So it's a kind of a platform kind of, it supports. You can connect to the
Yes. Okay.
cloud.
Again, why I mean, again, the developers have used Python. They chose Python in developing cross-platform supporting softwares.
Right.
So there is some technical thing that we are missing.
Yeah, I mean, it's more than technical. It
Mhm.
is the reason why people chose this Python is because of something called as AI. The
Oh,
initial AI practitioners, if you know that they are actually physicists or mathematicians
Yeah, I'm in that
or
field.
mathematicians that came into the area to explore their models or to build their models, implement their statistics and all. Right? They are not core computer science programmers. So what they want is a simple and easy language to implement their complex stuff. Getting?
Yep. Yep.
And
yes.
hence the early adapters of AI and ML have chosen Python, and hence the libraries have become larger for Python. No, people are meant to, or I mean, Python is the language that has the largest or largest libraries when it comes to AI, ML, and data related jobs.
Yeah, some MATLAB used to be, but now Python is similar to a MATLAB where they are having everything available.
Yeah,
Available.
it actually surpassed MATLAB if I'm not wrong.
Yeah, yeah.
I was thinking a similar thing about R. Like a lot of bio people use R, not because it's like very efficient, but because there's just a lot of different libraries that we can use.
Right. And again, R it's a programming language that is more capable of only statistics, implementing statistics. The other advantage with Python is it is much more general purpose programming language. It is much more generalizable. Like you can build a lot of generic applications using this programming language. For example, would you believe that Instagram's mobile application is built on Python? Mobile in the sense, web application is built on Python. And YouTube has lots of Python in its code. Also, using Python, people can build standalone computers, standalone softwares. Now, standalone softwares are nothing but the softwares that you can install in your computers, unlike the web applications. Okay, and hence Python is more general purpose programming language. Again, one more reason for being adapted across the industry. So Python has actually reduced the development time by, I mean, to a lot of, to a fraction of the original development time that it used to take using other programming languages. Today, as on date, everything is relying on speed. How fast can you release your product? That is the key KPI or the key performance factor in the industry, right? Python enabled that. And hence, Python is where it is now. Any questions so far?
So practically, once when we implemented it, we initially wrote the program on the Python and we ran. And then what happened is the performance was a bit slow. Then we converted to PySpark, then it becomes so fast. So probably,
Right.
Just want to give that heads up because yeah, it's powerful.
Yes.
But again, PySpark given we loaded like 1 million records in like probably in 30 seconds. Whereas Python is taking like more than 3-4 minutes. Of course, Informatica those days it took 1 hour time. Yeah.
Yeah. I agree. And the reason, whatever the other person, Venki Venkat, I guess, has mentioned, it is, remind me when, I will recollect this once
Okay, no
Venkat,
problem. Yeah, please
what do you
continue.
call it, reminds me of the same topic. Why PySpark is faster on Python? Okay. At the end of the day, PySpark is also a Python library, right? But why it is faster than regular Python? We will talk about that later.
Okay. Thank you.
Sure. No problem. So, any questions so far on the introduction to Python? So we have learned why Python, what is Python. So, yeah. Now, do you guys have any specific outcomes that you are looking forward to from this program? A 1 minute this thing question for you all.
So basically, for me, to understand the basics of the Python, at the same time writing the programs, whenever I can get a requirement, right? So I need to execute them. And I
What type
should
of programs are you expecting?
like programs like okay, let me like example in my world there are many things we can write, but in my world is basically to understand any requirements, right? And understand them, how we can simplify using new AWS or any cloud technologies. So for that pre and post processes. So instead of using previously like shell scripts and other database scripts. Now the goal is to implement the Python in a simple language. So I want to implement those things in my day-to-day and day out. Probably I would say that is primarily as a Python. And apart from that, now I need to learn AI too in future, but I'm still learning. So I'm expecting myself to use these concepts to integrate with the AI language and everything.
All right. All right. Anyone else?
Yeah, for me, I took like some Python classes on Coursera, but they use their own compiler or like they use their own environment. So I know a little bit about scripting, but I don't know anything about connecting what I scripted to anything that'll actually get anything done, like any outside apps or anything like that. So for me, I think the big thing I want to do is like figure out how to integrate my scripts into different figure out how to
Okay.
actually use my scripts.
Right. Okay. Okay. All right. Anyone else want to go or? All right. So the outcomes, as I mentioned, of this program is once you understand these constructs of Python, you can practically implement anything, be it machine learning, be it developing a web application, be it developing a standalone application. You can do a lot of stuff using the constructs that we are going to learn today. And we are going to learn some advanced and really important and useful concepts. Useful in the sense, like every construct is useful for sure, but the constructs that we are going to discuss during these sessions are a little advanced as well, which is going to help you when you are writing complex code and you want the help of efficient constructs available in the language. And whenever we are talking about efficiency, there is some complexity involved in learning the concepts, but they are worth that. All right? Right. So, as part of this thing, you guys, all of you have your Python black box installed in your computers. Am I correct? Okay. Now, once that is installed, we will come to other softwares like like VS Code that we have mentioned during the sessions later. But for now, let me quickly share my screen and fire up my Python interpreter, and we'll take it forward from there. I'm not sure what this thing you guys are using. I mean, what machines you guys are using, but I am using a Mac, and this is how things are going to be even on a Linux machine. If you guys are using a Windows machine, then you probably need to research it a little on yourself, I mean, by yourself on the Google. And yesterday I've shared some links and they should help too. All right. So can all of you open the Windows people, open your CMD command prompt and type Python and space minus uppercase V or capital V and hit enter. Hello, are you guys doing? Let me know if you have any issues with that. If any of you are not able to see something like this, where these numbers can vary, but Python space 3 dot, okay, that should be returned.
Is this
You
the
should be able to see Python the 3 dot something else, whatever number that you have got it installed. Yes,
okay? Mine is 3.8.5. Is that too low?
works.
Okay, cool.
No, fine, works.
Okay.
Is there anyone who is not seeing this? If you're not seeing this, it is probably because for Windows computers people, you don't have your Python path or the location. Okay, this is where Python is installed in my computer. So this is called as Python path. Now this path should be existing in your path environment variable in your Windows computers. If that is existing, then when you open your command prompt and type Python space -v, then you should be able to see this.
Okay. So
Okay.
if I use Python 3 and version as a command, I get that. But if I do like Python space minus capital V, it doesn't
Okay.
come in that form. So
Fine. Then Python 3 is your command.
yeah.
Okay. Now how to change that? Also changing that to Python also possible. All you have to do is go to your environment variables. But how to do that? Research on yourself. By yourselves on Google and get it done. If
Okay.
you wish to, or else you are most welcome to use Python 3 as your command. Anyone else?
No, the font is very tiny. So is there any way you can increase the font?
Sure.
Yeah.
Is this okay?
Yeah, that's fine. Thanks.
No problem. I'm using a big monitor here, so I may not find the difference. Please let me know, guys, if the font is smaller, seems smaller for you.
Little bit, probably 1 or 2
Sure.
points would help.
So when I do like which Python 3, so the path is looking different. Here I'm seeing the user bin Python 3, but you are in a Anaconda environment, right? So
Yeah. That's my base
let's
Python.
not be an issue for now.
No problem. As long as you have Python, you are good. Where, what, and all doesn't matter.
So you'll be introducing a bit about these Conda environments and all that stuff.
Yeah, we will talk about it, but it's very brief. But I will give you an understanding of what is Anaconda, what is Python, blah, 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 blah. But we will
Because
be
that's
mostly dealing with Python itself. Sorry.
when I stopped programming like 8 years ago or 10 years ago, it was not that these things were not there. Now they started talking about like whenever you want to run something, we have to be on a Conda environment. So there are like some sort of like missing bridges there for me to understand like
Okay.
why definitely we need to be in that environments and all. So that's something a missing piece.
Okay. You want the theory part of why we need
Yeah.
to be there and all. Okay. Okay. Basically, Conda is nothing but a software that is developed by the Anaconda people for being able to manage Python packages. Now, when we
Okay.
call about Python package, managing Python packages, what we want to do is make sure the version of Python package that we are using for a particular project
Mhm.
is consistent. Or, okay, how do you install a package on Python? So we will get there. When we get there to that particular this thing, since you have mentioned, I will also talk about the Conda and the Conda environment. Okay?
Thank you.
Sure, no problem. Right, guys. So if you have your Python environments ready and fired up, type Python and Python or Python 3 in your computers as required and hit enter. Now, what is happening behind the scenes when you type Python and hit enter is the python.exe file that you have in your computer or the Python package, the black box that we are talking about that you have installed in your computer, that is going to the operating system, underlying operating system, and asking the operating system, boss, I need some space in the memory. Now, a clarification. When we call out the word memory here in this context, then we are talking about the RAM, random access memory. Okay, it goes to the operating system asking for, boss, my owner has asked me or fired me up just now. I need some space in the memory to be able to perform whatever the user is asking me to perform. That is the request the Python box is going to make with the underlying operating system. And immediately, since the operating systems are very good these days, will give you with some memory. Okay. Which means now anything you type here is not going to go to your operating system. Outside of this, when we wrote Python and hit enter, here this command went to the operating system, right? Now, whatever we write here, it is not going to go to the operating system, but it is going to go to this black box. Now, this black box is going to convert this into the language understandable by the computer. And whatever result is given by the computer will be translated back to our language and will be shown here. Any questions there?
No.
All right. That is what we mean by typing Python or firing up your Python. And we call it Python interpreter. But for now, let us understand it as Python engine. Okay, because that is making things work. Or Python virtual machine. All right. Right. Now you have your Python environment or engine or interpreter ready and available for us to use. What we will do is use this interpreter as a calculator, performing 2 plus 3. 2 multiplied by 4. So basically, what we can do is the Python interpreter can be used as a, what do you call, a calculator. The most basic usage. Sorry, my bad. Now we are talking about something called as an interpreter, right? Does everyone here understand what is an interpreter and what is a compiler? What is an interpreter? Is there anyone who does not understand this?
I don't know the difference, and also when I try to type 2x4 into my CMD, it says it gives me an error. Let's see, what does it say? It says,
Which means if it is giving you an error, which means your Python interpreter has not fired up.
okay. Mm.
What is the error? If you can.
Okay. Okay. I think it might be messed up because I installed Conda in the past, and it says this Python interpreter is in Conda environment, but the environment has not been activated. Okay. 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 I think I can figure it out.
Okay, fine. Thanks.
Okay. Thank you.
Sorry. Now, let us talk about a little about the black box. Let us demystify the black box for a bit. Okay, when we said Python is a black box, right? That is translating whatever we are writing in here English into practically zeros and ones understandable by a computer. So how is it doing that? So before learning how is it doing that, let us learn what are the different ways of doing it. Basically, there are two ways of performing this operation called as translation. What it is doing is translating English into zeros and ones, correct? So there are two ways of performing this translation. One is called as compiling and the other is called as interpreting. Okay. The difference between compiling and interpreting is, let us say there is an author that has, what do you call, translated a book written in Sanskrit, let us say, not understood by many in the current world, into something in English, understandable by most people in the world. Here we are doing book to book translation, which means this book is already written and existing. The whole book is translated at once into this English language book. Okay. Now, this way of translation is called as compilation. Now, let us take a similar example. There is a speaker who has come to the United States, a speaker who can speak only in Sanskrit, okay, who has come to the United States and wants to deliver a speech in Sanskrit language. Right. Deliver a speech in Sanskrit to a audience. Okay. Now he will employ someone who can convert Sanskrit to English, but the conversion here happens sentence by sentence. Am I correct? Which means the Sanskrit speaker will be saying something, a sentence, and immediately the sentence will be converted into English by this English speaker, translator. Okay. Now, this way of translation is called as interpretation or interpreted. Now, coming to our programming scenario, when your whole program is converted to zeros and ones at once, then such a translation is called as compilation. When line by line translation can happen or is happening, then that's called as interpreted programming language. Any questions there? Anybody?
No.
All right. And hence, whenever we are giving here, we are able to simply write an operation and see the result in the interpreter. Okay. All right. Since we have already come across the term called as operation, let us try to understand the meaning of an operation. Can someone give an meaning to the word operation? Simply means getting something done, right?
Yeah.
Practically, getting something done by telling or instructing, whatever you say. Now, the basic operations, whenever we'll try to learn, okay, when we were kids, the first and foremost things that we learned were basic numbers, additions, some manipulations with the numbers, and alphabet, right? So similarly, we will follow the same procedure here as well. We'll start with numbers. Okay. Python also accepts, numbers of any size. The regular numbers that we have in the real-time world, the same numbers make the same sense also in Python. Sorry. Okay. Now, the manipulations between the numbers are called as arithmetic operations. Okay. The manipulations between the numbers are called as arithmetic operations. Now, examples of arithmetic operations are, excuse me, addition, subtraction, multiplication, division. There is something called as, there is a symbol to get the remainder of a function. Okay. And there is something called as integer division in Python. Okay. These are few examples of operations, arithmetic operations that we have in Python. Okay. Let's quickly look into them. So addition, we have seen 2 plus 3, 5, or let us say 4 plus 3, 7. Multiplication, we have seen 2 plus 4, 2 into 4, or 3 into 7, 21. Now, subtraction, 2 minus 1, what is the result? Hello? 1. 1 minus 2, what is the result?
-1 normally.
Yes. 3 divided by 2, what is the result?
1.5.
2 divided by 3?
0.7.
0.6.
0.75.
Yes.
0.6. 0.6.
Right? So there goes your addition, multiplication, subtraction, and division. Now the remainder. Okay. Now when you divide 10 by 3, what is the remainder?
1.
Right. But to get the remainder, we need to use the percentage symbol. Okay.
Okay.
When you want the quotient, you guys understand what is quotient and what is remainder, right? I don't have to iterate on that. So what do you get? What is the quotient for when 10 is divided by 3?
3, right?
Any questions so far in how to get the quotient and how to get the remainder?
So the 10 by 3 is the result, right? The 3.33 is the result.
Yeah, again, it is still it is a result, but it is a quotient, right? Okay. So when we say, sorry, 10 divided by 3, right?
Right.
We write
Three threes are 9, and then 1.
dot 0, again 3, 9, 0. Am I correct?
Yes. Forgot about it.
Yes,
Gone back again.
no problem. All right. All right, that is what division, and that is what this is what a remainder means, and this is the division the quotient means. Okay. Now integer division. All right, which means simply when we divide 10 by 3, okay, the result is 3.333, so on up to this thing, right? 3.33333 is the number that we get. Now, what is the integer part of this number?
Three.
3. Correct? Now, the integer division returns this value.
Mhm.
Any questions there?
No.
Which means when we say 10, here for integer division, we use double slash, forward slash. Okay. Now, when we say 10 double slash 3, what is the output? Okay, what will be the output?
3 is it? Yeah.
Okay. 100 divided by 6, double slash 6. What is the output? For your simplicity, first time we will do 100 divided by 6. Okay. Now 100 double slash 6. What will be the output?
16.
Sorry?
16.
Beautiful. The integer part of the division.
Okay.
Okay. This integer division is also called as floor division. Okay. This integer division is also called as floor division. Can someone guess why?
The floor is on the bottom and you round down.
Beautiful. So every decimal number, okay, every decimal number is between an integer. I mean, it's between two integers, correct? For example, let us say 2.5. 2.5 is the decimal value greater than integer 2 and lesser than integer 3. Correct?
Yes.
Hello? Yes.
Yeah.
Yes. So, and hence, when we are getting this value, we are calling it a floor division. Now, what does this value should be called as? When this is floor value, then what is this value?
I know there's
Hello.
float, but I don't think float's right. I don't know.
Okay.
Yeah.
The lower bound value is called as floor value. Sorry, someone else want to try?
No.
Okay, your audio is breaking if I'm not wrong. Okay, the upper value is called as seal.
Like ceiling.
That
Ceiling,
makes
exactly.
sense.
Floor and seal. Okay, so we have double forward slash to get the floor value of a division. Now, your assignment question is how to get the ceiling value of a division. Sorry. How to get the ceiling value of a division. Now, that is your problem statement. Okay.
Okay.
Right. These are few, what do you call, mathematical operations that can be performed. And the symbols are called as operators. Okay. And the values are called as operands. I don't think I have to say that. But there we are. All right. Once we are done with arithmetic operations, the next thing that we will look into is assignment operations. Okay. Assignment operation means assigning something or assigning a value to a variable. Okay. So assignment means simple assigning something or giving something to something. For this operation, the basic symbol that we have is equal to. Equal to is the symbol that is used to assign something to something. Okay. Assigning a value to a variable. Now, before getting into the implementation of the assignment operations, I think we need to understand something called as a variable. So is there anyone here who does not understand the concept of a variable? What does a variable mean? A variable is nothing but a placeholder that could hold a value. Okay, which means, let us say in algebra, in maths, we say x and y, right? X and y are placeholders. In one equation, they can carry a certain value, and in another equation, they can carry a different value. Am I correct? Similarly, a
Variable value.
variable, sorry?
Oh, sorry. I said they got variable value. Like their value can be variable.
Okay. So, yeah, a variable is something that can hold a different values at different points in time. Okay. For example, let us say date is a variable. It holds a different value yesterday and it is holding a different value today. Am I correct?
Yeah, that's right.
Similarly, variable is a placeholder that can contain or hold a value. Right? Now, what kind of values a variable can contain?
Depends on
When we pose this question, the first thing for us to talk about is different types of values existing. Correct?
Yeah. Yeah, it can be numerical or it can be anything. Different type of values can be given for a variable.
Right. Right. So, what are the different types of values existing? Can someone
So
mention?
I think we just saw an integer which has a decimal added to it, which is like float, normally
Yes.
floating, and a character. I don't know.
Strings.
Thing. Yeah.
In Python, we call them as strings or characters. Yes. And Python also offers another type of values called as, if you remember the complex numbers concepts from mathematics.
Yeah, like which will have the imaginary in
Part to the number, right? Exactly. So these are the fundamental types of values existing in programming or in Python, basically. Okay. Now, whenever we are calling a type of value, right, different values collectively are called as data, right? Which means we can say that my bad. Okay. So these are different types of values or different types of data existing in Python. Now, that leads to the term called as data types. Okay. Now let us talk about the data types. We have seen what different types of data are existing in Python. We have seen what integers are. Integers are numbers without a decimal point. Floats are nothing but numbers again with a decimal point. Simple as that. Now, when it comes to strings, okay, anything written in single quotes, or double quotes, or something called as triple quotes. Okay, anything written in these quotes are strings, are considered to be strings in Python. These are the 4 ways in which we can define or identify a string. Any questions here? We will get into like details of strings a little later, but yeah. If this is understood, then let us look into what is called as complex. So complex numbers are those that carry an imaginary part in the number. Okay. Now, what do we mean by imaginary part? I hope everyone remembers or is able to recollect the concept of complex numbers from mathematics, from schooling? Or do you want me to explain the concept of complex numbers as well?
maybe
Hello?
quickly, briefly, very quickly.
Okay. Okay. Nice. Can someone tell me what is the root of square root value for the square root of -1?
I.
And even before that, yes, yes. Why? What do you mean by I and why I?
Uh, I just know it's like imaginary because you can't take the square root of a negative number, because if you did the inverse, you wouldn't end up with anything.
Beautiful. I mean, actually, but one thing is there cannot exist a square root for a negative number. Why is that? Because what is the result of -2 whole square?
+4.
Yes. What is the result of 2 square?
4.
Which means for a negative number, be it a negative number or a positive number, whenever you are doing a square, the result is always positive. Am I correct?
Yeah.
Which means when you say square root of 4, what is the value?
Always it's 2.
Sorry?
So 2.
Plus or -2, right? It could be anything.
Yeah, that's true. Yeah, because it can be -2 whole square or 2 whole square, so it should be plus
It's
or minus.
plus or -2. Now, square root of -4,
You cannot assign something.
how people came across solving this is by writing it as -1 whole root into square root of 4, which is 2 into square root of -1.
Yeah, which becomes
And
2i, I2 or something.
yes, and since -1 does not have any real value to it, they have substituted this with something called as an I, saying 2I, which means I is equal to square root of -1. Then what is I square?
-1.
-1, which is nothing but root of -1 whole square. That is equal to root of -1 multiplied by root of -1, which is -1. Any questions, anybody?
No.
Beautiful. Now, for the convention purpose, in Python, this I is represented by something called as J, which means 2I will be represented as okay, 2I will be represented as 2J, or 0 plus 2J is how you can represent a complex number in Python. Any questions, anybody? If no questions. All right, we'll try implementing this thing, right? Control L. Now we'll see. 0 plus 2J. What we will do is whole square. Okay. Sorry, into 0 plus 2J. Okay. And what should be the result of this? 2j into 2j. Guys, quick.
So that's
2 into 2, 4. J into j minus 1.
minus 4.
Minus 4 plus 0j. Right. Now, when it came to arithmetic operations, we've looked at addition, subtraction, multiplication, division, blah, 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 right? We have forgot looking into something called as exponentiations. Okay. Let us say we want to find out the square of 3. This is one way to write that, right?
Wait, I thought that. Yeah. Would that just be 3 times 3? Not 3. 3
No,
to the power 3?
this is no. This is a single asterisk operator, right? That is multiplication operation.
Yeah.
Now, if we want to find out 3 cube, then using multiplication, we can say 3 star 3 star 3, right? But that is a little bad, or where you have to put in more effort. We can actually, with lesser effort, we can represent or say this as 3 star star 3. Now that the double star asterisks represent to the power of 3 to the power of 3. 3 to the power of 4, which means 3 into 3 into 3 into 3. What is 27 times 3? 81, right? Yeah, any questions here with respect to complex numbers and exponentiations?
Can you also do 3 caret 3, or is that a different language I'm remembering?
That's a different language.
Okay. Thank you.
Let's try that. No, that's a different language. Here it's a different operation. Yes. Any other questions, anybody? Okay. The time is, when do you guys generally go for have your lunch?
Maybe 12:30.
Around 12:30. Okay. Then you guys okay with continuing the sessions till 12:30 with a quick 5-minute break now?
Yeah, 5-minute break. Yeah.
Sure. Thanks. Hello, everyone. Hope everyone is back. All right. So let's quickly dive into we have gotten ourselves introduced with numbers, float, complex, and strings. Let's quickly dive into something called as variables. So variables can be anything. The naming conventions has very few number of rules where you cannot start a variable with a number in Python, like 1_a or something like that we cannot use. And there are very few symbols that can be used in a variable, and underscore is one such symbol that can be used in a variable. Okay, which means you can also start a variable with an underscore. Okay, underscore var. This can be a variable, a valid variable in Python. All right. But a variable name cannot start with a number, one var, let us say. Invalid decimal literal. Syntax error, basically. Okay. Are you guys there? Everyone, are you back?
Yeah.
I'm here.
Okay. All right. So variable is nothing but a placeholder that can hold any value. Now, when it comes to data, we have seen something called as data types. In other programming languages, if you have been familiar with, we have something called as data types for the variables, right? Here in Python, there is no concept of data type for a variable. We have the types are existing only for data. Okay. Type exists only for data, but not for the variable. But whenever we try to check the data type for a variable, whenever we try to check the data type for a variable, Python will intelligently return the type of the value it is holding. Okay, whenever we try to check the data type for a variable, Python returns the type of the value it is holding. Any questions there? For example, to check the type of a value, we have a function or a built-in function in Python called as type. Okay, here if you give 3, what should be the output for this command? When you say type of 3, what type of value is it?
Integer?
Mhm.
So do we have to be careful when we're adding like 2 different variables? Will it add it anyway if they're not compatible?
No, it will not.
Okay,
For
cool.
example, let us take a variable called a, let us put 3 in it, and let us take another variable called b, and let us put in quotes 4. So what is this value?
Wait, okay.
Integer or a string,
Oh, a string.
right? Okay. Now, what do you think will be the result for a plus b?
That wouldn't work.
Right.
Okay.
Type error, unsupported operand type plus between integer and a string.
Okay. Okay, cool. Thank
Okay.
you.
Sure, no problem. Now, how to check the type of a variable? You write a type and then pass in the value, right? Now, what will happen when we say type of a? Any guesses, anybody?
Integer?
Why so? Because data type does not exist for a variable, right?
Yeah.
Still, how is it returning integer?
But we assigned it. We changed data type to an integer by assigning a 3 to the.
Okay, then what is the default data type for A?
So it doesn't have anything.
Beautiful. Yes, when it doesn't have anything, what is the data type of A?
It's like a wow. It's like a string or character.
No,
it-
it cannot have anything. It's not a variable, and it is illegal for having an empty variable in Python. In just a bit, you'll understand why is that so. Okay,
Okay.
right. We cannot, okay, just the reason for stating this statement again is that, like in other programming languages, we cannot declare variables in Python. We can only define them,
Mm.
which means there cannot exist a variable that is not having a value with it.
Oh,
In this
Okay.
scenario, it's complaining about which one? It's complaining about the B or
Here,
yeah.
it is complaining about the operation that we are trying to perform
Oh, between
between two different data types. Sorry?
yeah, understood.
Yes. It
so
has no problem with A or B. Yes.
how? This might be a silly question, but how does it know that something's a variable? Like if you just typed in. Okay, so it knows numbers aren't variables, right?
Right.
Like, okay. Okay, so does it just, if you just type in a letter, like and it's not a command, it's not a number, it's not an operator, like, does it just assume it's a variable?
That's a beautiful question. Now, before we got here, we were talking about, we started or we incepted the concept called as assignment operator, right?
Yeah,
We just mentioned it, but left it there
okay.
for this reason, to get back to that concept right now. Okay.
Okay.
So how does statements like this execute in Python? Okay. What happens when, as soon as this statement is given and hit enter is hit, and you hit return, what is happening behind the scenes is Python is actually translating this into a computer language. Okay. Now, there is a symbol or a operator here, right? And we said that these two are operands, right? Now, 3 is a value, right? So what is happening here is, one second. Okay. Right. Initially, when we said Python, as soon as we hit type Python and hit enter, we told that it goes to the operating system and asks for some memory space. Correct?
Yeah,
Yes, it got some memory space. As soon as it received the memory space, what Python does is, the black box does is, it divides this memory space into two parts. Okay.
okay,
Now, one of the parts is called as value heap. Okay. And the other part is called as variable heap.
okay.
Now, what do you mean by heap? Anybody?
Um, is it just a value, like a character?
No.
Okay.
Heap means contiguous locations of memory.
Okay.
or contiguous spaces of memory, which means this contiguous spaces of memory is called as one heap, and this contiguous space of memory is called as another heap.
Okay.
Okay. So
But in
now, as soon, sorry,
heap is like collection of things, right? Like lot of.
memory space. Yes, yes. Here, when we are talking about variable and value heap, we are talking about collection of memory spaces. Precisely a contiguous collection of memory spaces.
Okay.
Okay. Now, as soon as we typed a is equal to 3 and hit return here, what is happening is such statements in Python get executed from right to left fashion, and
Oh.
Python takes this value first. Okay, takes this value first and comes to the value heap. Okay, and checks for the existence of the number 3 in the value heap. Is it existing?
Now it is.
Not yet, right? See, as
Okay.
it just came across this line, it's this statement, it just came across this statement. The statement is being processed, not yet processed completely.
Okay. Okay.
In
I
that
have
stage,
another question. This might be for later, but if it goes from right to left, do we have to like worry about PEMDAS? Like
sorry,
do we have to worry about like the order of operations if it executes from right to left, do we have to worry about?
all right. So I am talking about the statements with equal to symbol in them.
Okay.
Okay, with a single equal to symbol in them, to be more precise.
Okay.
Okay,
Okay,
which
so
means as soon as Python, yes.
it's just at the equals that it goes right to left. So if we were doing like a long equation, it'll still follow order of operations from left to right.
Yes, order of operations from left to right and the regular baud mass.
Okay, cool.
Yes, beautiful. Okay, so it takes this number, comes to the value heap and searches for its existence in the value heap. As of now, it's not existing yet, right? So what it does is it takes a memory space at random and puts the value 3 in it. Okay, now goes back to this statement and takes this thing. Since there is an equal to symbol in between, all it does, it decides that this is a variable. Okay, this is a placeholder where he wants to store this value, hold this value rather. Okay, so now the value has been processed and put in the memory. It takes the variable, and that is how it understands that this is a variable, and comes to check for its existence in the variable heap. As of now, even the variable is not existing. So it takes a variable space at random, excuse me, okay, and stores the variable in it,
Okay.
right? Yeah,
So I guess it's like if it's not defined, it just doesn't exist.
exactly,
Okay.
exactly. And hence, I mean, after this, it has placed 3 in value heap and a in variable heap and points this variable to that value.
Okay, okay. Okay, so things like operators are already defined. So okay.
Yes,
Yeah,
that is how the
so
operator is already defined, right?
okay. That makes sense. Thank you.
No problem. All right. Now, what do you think will happen when we say B is equal to, in quotes, 4?
That's a string
Should
because
be
it's in
it.
quotes, right?
Yeah. So
So it's puts 4 as a string in the value heap.
beautiful. Since it is not existing, it puts somewhere over here, maybe anywhere in the memory at random.
And then once the B comes up, then it will assign it to it, right, in the variable heap.
Beautiful. Right? Beautiful story. Very nice. Now I will say in the next line, B is equal to 3. Now what do you think will happen?
That's an integer. So then it
So it will first execute the 3, but there in the value heap.
Right.
And now it need to assign that 3 to the B, then A becomes irrelevant. Right?
Sorry?
It will assign to the B as per the previous operation. And now A will not have anything assigned.
Yeah.
Why is that so?
Wait.
Oh, I mean, that's a confusion I have now. So but it can.
Okay.
Yeah.
Yes, exactly. Now, see, the B is existing in the memory and the 3 is existing in the memory. What it does is, it just assigns B or makes the variable B point to the same existing value 3 in the value heap.
So, okay. So in the value heap, each value can also be assigned to multiple variables.
Perfect.
So what?
Now, yes. Yes, you have a question.
I mean, what happens to that string?
Beautiful, beautiful. We will get there. We will learn that. Okay. Now, when we say type of A, what will be the result? So,
Integer.
It's still an integer. Yeah.
right. Why? Because type of A means type of 3.
Yeah.
Right? Now, what is type of B?
It's still
B?
because it was changed.
Type of 3 also means, B also means type of 3, right?
Yeah.
Yeah. So integer.
Integer. Right? We will check that first. Okay. Let us make the change. We said A is equal to 3, right? We'll say B also is equal to 3. Okay. Now let's check type of A, integer, type of B, integer. Okay. Now, any questions so far?
Nope.
Hello?
Oh, no.
I think you're going to explain
Okay.
what happens.
Yeah. Yeah.
Yes. Yeah, you guys understood this part, right?
Yeah.
Yeah, we'll go to the next part now. So we have learned that now apparently B and A, both the variables are pointing out to the same value in the value heap. Why do you have to believe me on that? Because I'm saying so, because I have the credibility, because I've been working with Python since 12 years. Is that why?
Because I don't know, this might be silly because the equal sign reassigns, right? Like, I
Yeah,
don't know.
but how do you, okay, this is my explanation in my diagram, right? But how can we prove this? To prove that, we have something called as ID function, a built-in function in Python. Okay. What does this function do is, whatever value you pass to this function, it will return the address location or memory location. Okay, address or memory, address in the memory or an identity of that value. Okay, an identity of the value in the from the memory. Okay. Now, let us say ID of A. ID of A means ID of 3, right? Any questions on that part?
I guess we'll see, but I don't really know what ID is asking for.
Okay, so that's what I'm telling you. The definition of ID is it returns the address of the value in the memory.
Okay.
Right. Okay.
Right? Since the variable A is pointing to the value 3, whenever we say ID of A,
It will.
it should return the ID of 3.
Correct.
Am I correct?
Okay. Okay.
Yes. When we say ID of B, what should it return?
B. No. 3.
ID of 3 itself, right? Which means these both IDs, ID of A and ID of B, must be the same. Am I correct?
Okay.
Yeah, that's correct.
Let us verify that.
So I think there is a small confusion there for me is A also is somewhere stored in the memory, correct?
Right. Right.
So normally whenever I say like where is A located, it should tell the location of the A, but
Beautiful.
instead here it will actually give the
Okay.
location of the assigned value to that variable. Is that
Right. So, the reason being, what is the point of having the memory location of your variable?
Mm,
I guess.
not-
Is it
I
because
mean, that,
like
see,
no
okay,
matter sorry. No
no
matter
problem.
how many
So,
times you've reassigned it, you can figure out what it is now?
okay. So I didn't quite understand what you said. Can you repeat that?
Oh, I guess like maybe it's because however many times you've reassigned it, you can figure out what it is now without like having to scroll back through your code.
Yeah, okay. You are telling why the ID function is returning the ID of or the memory address of the value, but not the variable itself.
Oh.
Am I correct? Are you trying to answer that?
Yeah.
Yeah. Yeah, it is for that reason. But my point is, which is, I mean, yours is very much valid. The same thing I want to ask put it in a different way, which is, what is the point of having the address location of the variable? At the end of the day, we are concerned, we cannot have a variable without having a value put in it.
Yeah, right.
And it is the value that is most important in the program.
Yeah.
Variable is just a placeholder.
The value is the one which is giving the status for the variable to exist. So,
Exactly.
Yeah.
And hence, everything in Python is value driven or
Yeah.
data driven.
nice. Nice. Okay.
Right. And hence, now we have established the reason, right? Now let us check whether am I correct or not. Okay, so ID of 3. Let us first check the ID of 3. Okay, it is so and so value. My bad, sorry. What we will do is, let's repeat the step again. Okay, ID of 3, it is so and so value, right? Let's do ID of A. What do you think this should return? Which number should this return? The same number as above?
Yeah.
Right. Now, ID of B. What do you think this should return?
Same thing,
He's still
because it's still pointing to the 3.
Now, is our statement correct?
Yes. So we
Alright.
basically validated whatever the theoretically we decided.
Exactly.
yeah, I mean I
Right.
guess whatever the computer says is probably correct.
Yeah. Now, coming back to Venkat's question, what will happen to the empty hanging value, the string 4 in the memory?
Technically, it should be, it's an orphan, so it should be taken out, or that doesn't need to keep it.
Beautiful. Now enters the concept called as garbage collection. Okay, what does garbage collection mean?
So all these values that doesn't have an assigned variable has to be, is useless, so it has to be collected in the garbage. It has to go to the garbage.
Exactly. Yeah,
The left,
they have to be deleted basically. They have to be, the memory must be freed in simple terms.
Yeah.
Right, for future use.
yeah, like in a refrigerator, the leftovers, we take it out and put it in the garbage.
Put it in the mouth. Sorry. Yeah. So that's what basically garbage collection means. Right. So how does garbage collection happen in Python? Is that it follows an algorithm called as reference counting. Okay. I'm really sorry. My pencil is acting up very weird today. Yeah.
We can manage
Okay.
that.
Thank you. So reference counting. So what does reference counting means? This is a program built into the Python black box itself. Okay. Apart from whatever we write being converted to the computer language, sorry, there is another small program in the Python box called as reference counting program. It runs every time and again at scheduled or regular intervals. And what those intervals are not our problem as of now. Okay. So it runs at regular intervals. And what it does is it goes across the whole value heap and the whole variable heap. Okay. And finds value. Okay. As soon as it sees a value or a variable, it starts counting the number of references it has in the memory. Okay. It counts the number of references it has in the memory. Right. So whenever it comes across a variable or a value with 0 references, in this case, our string 4, whenever it comes across any variable or value with 0 references, it just garbage collects them.
How does that variable even get in there though?
Okay, when we created b is equal to, it's not about variable but value. When we created b is equal to 4, it got in there, right?
Okay.
And then we reassigned b to 3. And then this has become an orphan.
Okay. Okay.
Yeah. Any questions there? Now, this is how memory management happens in Python.
Nice. So Is it not available in other languages? Is it like a special feature of the Python, and it's an advantage?
No, it's available in other languages also. Garbage collection is a regular process in other languages, but the method is different in other programming languages, like in Java or C or C++, where you can have variables being declared but not defined, which means you can have variables that do not have any value with them.
Okay.
And hence the technique over there is different
Different. Okay.
from how it is in Python. Yeah.
So when some people write programming, they don't need to bother about these reassigning and then the leftover values. So they use in the logic like reference counting
Simple as that. Simple.
to understand how much garbage it's collected at a given time.
Right. We don't have to bother about it.
Okay.
But in programming languages like Java, also one needs to take care of it time and again, depending on the complexity of your problem and the available RAM in your computers. But these days, even in those programming languages, you don't have to worry about, if I'm not wrong.
Okay.
Because back in the day when I started programming, we used to have a RAM of 64 GB RAM is used to be very expensive. Sorry, 64 MB RAM used to be very expensive. I bought my first laptop in 2007.
Mm-hmm.
Yeah, so in those days, programs used to get really quite a bit heavy. I mean, could get quite a bit heavy, and we had to manage memory sometimes by ourselves. But these days, with all these 24 GB RAMs and 36 GB RAMs, you don't have to bother much, and the programming languages also become quite sophisticated. Yeah, so not much worries there. But that is how memory management internally happens in Python.
Okay.
So if everything is taken care of internally, why do we have to bother? Why do we even have to bother about how memory and variables and values are created in Python?
I guess we just have to make sure to remember like which which number you assign to which variable last. I don't know.
No, you can always type that variable name and hit enter, or print that the value being contained in that variable, and you should be able to find the value.
Okay.
Okay. Remember this question and ask me when we talk about data structures. Okay. There we can see the what do you call, the impact that this has in in handling our data and programming and variables. All right. Any questions, anybody? Okay. Since we are done with that, you guys all installed what do you call, VS Code in your computers?
Yes.
All right. Let me open my VS Code then. Okay, let me close this, close this, close this, and constructs of python.py. All right. By far, we have seen programs where we have opened the Python interpreter and typed in whatever we wanted to execute and hit enter. Right. Now, when I say A, it is printing a value. When I say B, it is printing a value. But what will happen when I exit from my interpreter, okay, and get into my interpreter again? Now, if I type A and hit enter, what do you think will happen? Do you think it will still show 3? or it will give an error?
I think it will give an error.
Yeah.
Yes. Because as soon as you exited from the program, the memory being taken over by Python is trashed.
Yeah, I think that's why, like, I don't want to take too much time away from people, but like, I couldn't do any of the calculation stuff on my terminal because I had installed Conda and I didn't know how to uninstall it or like exit out of it. Um, yeah, but
Okay.
I don't want to like take too much time away from other people.
Okay, what we will do is we will take a break in some time, right? Maybe in about, we'll take the break at 1 p.m. Eastern time, because there are few people joining from the central time as well, time zone as well. So 12:30 Eastern time would be way too early for their lunch. Okay, we'll what do you call, disperse at 1 p.m. Eastern time and regroup at let us say 2 o'clock Eastern time, 2 p.m.
Okay.
Okay. Do you think 45 minutes would be enough, or do you want 1 full hour?
45 minutes, I think for me it's good, but we can hear
Okay.
from.
Then we will regroup at 1:45 p.m. All right.
Yeah.
Yes. So we have few minutes more. So Hillary, what we will do is, if you could finish your lunch sooner, then we can group and look into your computer's
Okay,
issue.
I might just need to type like exit or something, so or quit or
Okay.
I don't remember, but I'll try. I'll try some things. Thank you.
Sure. All right. All right, guys. So, and hence the programs that you write here in this interpreter or in this prompt directly are volatile. As soon as you exit out of this prompt, nothing is remaining, nothing is left. You cannot reuse whatever you have written so far, right? Hence comes the concept of reusability. Now, from now on, any concept that we are learning or we will be learning in the language is for maintainability, reusability. Okay? Right. Let's exit out of this interpreter. Right. Now, how can we write programs that are more non-volatile or that you can reuse multiple times? To do so, what we have to do is we have to create a file with an extension .py in it. Py standing for Python, of course, and obvious. Okay. Now you have a .py file. You can run that py file. Let us write print okay. You can run this py file from your terminal, okay, by saying Python. Since it is Python for me, for people who have to invoke their Python engine using Python 3, you need to write Python 3. So Python space my file name, which is constructs of python.py, and hit enter. Now, how many ever times I hit enter, the program can be run those many number of times or will be run those many number of times, and the result will be given out. Any questions? Right. Now, this is our first new line in Python. Now, to print anything to the console, right? To print anything to the console, we need to use a built-in function in Python called as print. All right. Now, just to bridge the gap between our what do you call interpreter coding to the file-based coding, let us take up the same example again. A is equal to 3, B is equal to 3 also, and we'll print ID of A, ID of B, and ID of 3. Okay, that is A itself, and okay, let's go and run this again. You see, memory address changed, but it is consistent between the 3 value and the variables. Any questions so far?
No.
Sorry?
Yeah,
All right.
everything is
All right. Now, it is fine that these are only 10 or 11 digits. We are able to check and able to confirm if these two numbers are same, right? What if we have tens of numbers? For example, let us say let's comment this. What if I want to check if and these two numbers, what if I want to check if these two values are same? We'll go and run this program. Since here the numbers are what do you call quite different, we are able to do so. But let me take a better example. Okay. Okay. When we have large numbers, by looking at the number, do you think we can decide whether the numbers are same or not, or whether two given values are same or not? For example, let us say we have values like and values like this thing. If I have to like ask you to compare these two values, let us imagine only one of the numbers in between are different. Okay.
Yeah, it's harder.
Right. So let us say something, we have another number. Now, if you compare these two numbers, do you think we can look at the numbers immediately and be able to say whether both the numbers are same or not? We cannot, right? And for that reason, we have something called as comparison operators. Okay. Now, using comparison operators, we can compare two values. Okay. Now, let us say we have, escape, A is equal to, sorry. Let us say we have our A is equal to this thing here, and we have our B equal to this thing here. Okay. We can use the comparison operator to check if these values are greater or lesser. Print A greater than B. Print A lesser than B. Okay. Now, the comparison operator, whenever you are comparing two values, the resultant is always either true or false. Am I correct? Hello?
Yeah.
Whenever you are comparing two values, the result is either true or false. That is the only thing that can a comparison operator can return in. Right?
Correct.
And hence, here, let us run this program and then check. Which means when you said A greater than B, it returned true. When you said A lesser than B, it returned false.
Okay.
Okay. Or in simple terms, now what we will do is 1 second, just a second. All right. All right. Yes. We are back again. All right. So what we will do is let's have different values to these. A is equal to 3 and B is equal to 5. Okay. Now what we will do is print A greater than B. What should be the result of this?
False.
Right. And let us have this on the this thing. Sorry. All right. All right. Control L. Right. Able to see my screen? Is the font visible?
Yes.
All right. Here, I think I need to increase the font, right? Is this fine now? Both sides?
Mm-hmm.
Right. And hence, when we compare here and do enter, it is false. What will happen when I say A is less than B?
Should print true.
Got it? Hello?
Yeah, yeah.
What if when I change the operands positions?
It should still print something.
True or false? B less than A. Is B less than A?
False.
False. Right. And just like that. Greater than A.
It's true.
Now B is greater than or equal to A. True or false?
Should true, right?
Yeah, true.
Yes. Sorry?
Oh, I meant to say true.
Yes, yes. because B is greater than A, but not, though not equal to A, it is greater than A. Right? Now let us say my A is 5. Now B is greater than or equal to A. Is B greater than A?
No, but
No,
it's
but exactly. Now what will happen when I say B is less than or equal to A?
still gives true.
Right? Now how
Bas-
to compare if B is equal to A? Or exactly equal to A. How do we compare B is equal to A? Since the single equal to operator is called as an assignment operator or used for assignment operations, the double equal to operator is used for comparing if two variables are equal or not.
Okay.
Any questions, anyone?
No.
All right. So these are the comparison operators we have called as greater than, less than, greater than equal to, less than equal to, double equal to. And there is another operator called as not equal to. Now, A is equal to this thing and B is equal to this thing, right? What we will do is let's get to here and we are checking if B is not equal to A. Is it equal to A?
Is true? True.
Not
Yes, true.
Yes. Now, let us say B is also 3.
False. Because they are true. Because they are equal.
Yes.
I mean,
Equal. Right. Any questions with the logical operators and operations?
no.
All right. In that case, let us get to the next operators. We have seen a single operator, assignment operators, right? In the assignment operator or assignment operations, we have seen something called as equal to. There are other assignment operators as well, called as plus equal to, minus equal to, slash equal to, star equal to, star star equal to. So what does this mean? Okay, when we say A is equal to 5, we know what is happening. Okay, now, which means the value 5 is stored in A, correct? Now, what we will say is A plus equal to 10. This simply translates to A is equal to A plus 10. This is the meaning of this operation. Which means what is the final result of A?
15.
How much?
15.
15.
Right? Let's print A and check. Voila.
Mm-hmm.
All right. Now, similarly, let us say we do not have B defined. Or do we? No, we do not have B defined. Right. Now, we will say B plus equal to 3. Okay. If you try printing B, what do you think will happen now?
It
A.
throw an error
Why?
Oh.
because B doesn't have any value assigned.
Initial value, right?
Oh.
For this operation, the plus equal to happen,
Because it
B
is
should have exactly some value in it. Because this means nothing but B is equal to B plus 3, correct?
Mm.
But
Yeah.
what is the initial value of B? We do not have one.
Mm-hmm.
And hence, voila.
B is not defined.
Any questions so far? So these operations, for these operations to execute, we need to have initial values for the variables. All right. Now, what is the value in A?
15 right now.
Right. Now, what we will do is A is equal to, A star equal to 3.
That should be like
Again, I will say print A.
Is that
What is the value
A
stored in it?
times 3? Times 3? So 15
Yeah.
times 75?
45.
Wait, right?
15 times
No,
3 is
that's not right.
45.
45.
Yes. Okay. Now what we will do is
Slash.
beautiful slash. Now what is the value of A?
5. 15 by 3, right?
45 by 3, right?
Oh, it's already have 45. Yes, yes.
15.0. Now what do you observe here?
It's calculated it and put it as a decimal value because
Right. Which means basically the slash operator returns
a float.
a float value always.
Hmm.
Even if it is an integer, as in this case, it puts a dot 0. But when you say double slash equal to 3, what will be the result now?
Integer.
15. Because it is an integer division, right?
Mhm.
All right. Any questions with these assignment operators?
So basically there is like plus, minus, star, slash, and double slash before the equal to.
Right. Double star also you can use if you want. Like for in this case, A is 15, right? Okay. A star equal to 3.
It's like a square of the value.
Yeah, A star equal to 2 is the square. A star equal to 3 is the cube.
Okay, okay, okay.
Okay. Now, for the simplicity of the calculation, what will be the value of A?
It's
15 square, which
20,
is
220.
225. Any questions with assignment operators?
No.
All right. Now, logic operators. We have 3 logic operators in Python called as AND, OR, NOT. Okay. So, AND returns, let us say we have true and true. You know what does AND refer to, right? Okay, AND is an operator that takes 2 values, okay, on either side. If both the values are true, only then the resultant is true. Okay? Only if both the values on both sides are true, only then the resultant is true. Don't be confused. We will look at a better example also. Okay? Now let us say A is equal to 5 and B is equal to 5. Let us say 4. Okay. Now here our condition is A greater than or equal to 5. Right? And A not equal to B. Okay,
So
which means it is comparing if A is greater than or equal to B. What is the result of this operation?
it's true.
Right. A is not equal to B. What is the result of this operation?
True.
Now, what do you think will be the final output of this calculation?
So if we are using AND operator. If both of them are same thing, then it will return that value, right? Because in this case, it's true for both, which means it should do true. Sorry, true.
True.
So if
Okay.
both of them
Now,
are
yes.
false, then it will put false, right?
Yeah, if both of them are false,
Okay.
okay, which means let us remove this and let us put this. Okay. If is A greater than B? True. No.
That's
Is A less than B?
like false, yeah. And then second
If
one is
A equal to B? False. Now, when you run this, it returns false. Now, what will happen if this statement is true? A less than or equal to B?
I think in both scenarios it
Is
should
false, right? So what we will do is let us change this scenario. Okay. Is A less than B?
false.
Yes. Is A not equal to B?
True.
No.
It is
What
true.
is the result of this operation?
Should be false, right?
Perfect. In the end condition, as long as both the outputs are not true, the result is going to be false. Which means, in other terms, print true and true. Okay. And let us check otherwise. True and false. False and true. False and false. Okay. Let us forget this for now. When we run this, what do you think will be the output for this line? Lost everyone already, I guess.
That should be true.
Right. What will be the output for this one? True and false?
False.
False
then
and true?
and the last one is false. Yeah.
Okay, this one?
That one also should be false.
Right. As long as both the operands of the AND operator are not true, it is going to be false. Only when both the operands are true or both the operands get evaluated to be true, only then the resultant will be true.
Okay. Nice.
Any other questions, anybody? I mean, everyone fine with this? Any questions, anyone?
No, Gautam, it's good.
All right.
Do you
Now,
have any
in
lunchtime
this
break,
scenario,
something? Do you have a lunch break or?
yeah, in 10 minutes at
Okay,
1 o'clock. Oh, yeah,
thank you.
sure. Yeah. So when you have with the OR operator, as long as both the operands are not false, the result will be true, which means true or true. What do you think will be the result?
I think it's true, and then
For
and
this,
then
true or false?
It's true.
right? False or true,
It's also true.
right?
And then
Only when both the operands are false, the result will be false. Just to remove any this thing. 3 trues and 1 false. Any questions, anyone?
No.
All right. All is just the right. Okay. With this, we are done with operators. I think we can call. Yeah, there are other operators also, but we will learn about that when the time arrives. All right. Now, we need to learn about 2 other data types in Python since the time has arrived. So we have learned about not numbers, let us say integers, float, strings, and complex numbers, right? Now let us learn about other special data structures called as bool and something called as none. Okay. None is a data type in Python. We will learn about none in a bit, but let us look at bool. Okay. This data type means nothing but Boolean values. Okay. Which means there are only 2 values that can be of this type. True with a capital T or an uppercase T, and false with an uppercase F. So when you say print type of true, it will return bool. Any questions?
No.
And similarly, when you say print type of false, again it returns bool. So we told in Python there cannot be variables without having a value, right? And hence, if you have ever come across SQL programming language or databases or something, we have something called as null values in those programming languages. Am I correct? Similarly, we have a data type called as none type. And there is only one value of this type called as none with a uppercase N. And that is how you can create a value with practically, a variable with practically no value in it. But even this is actually a value that is none is a value being stored in the memory, and A is being pointed to this value called as none. Okay. Now let us print the type of A. Class none type. Any questions, anyone? Hello?
Yeah, nothing.
All right. So with this, we are done with data types and operators and operations in Python. Okay, so let's break for lunch for now and group back again in 45 minutes. Let me share my clock screen and Your time starts now. Thank you all.
See you guys later.
Yes, let's go back in 45 minutes and continue. everyone back?
My cat's annoyed at me for being on the computer all day.
Sorry, I didn't get that. Can you come
Oh,
again?
my cat's annoyed at me for being on the computer all day, so I'll go turn on her automatic toy.
Okay. Sorry?
You can mute him, right?
Yeah, I think I can mute him. Just a second. I can request to mute. No. Yeah, I think I muted him. All right. All is just the right. Okay. All right. Let me share my screen quickly and get back to our functions in Python. All right, so we have learned about what we called as positional parameters and positional arguments and keyword arguments. We are done with that, right? Now let us talk about something called as default arguments. Okay. The default arguments are the arguments that you pass while defining the function itself. For example, let us say we have M3 here. We want to say the default values for all these three marks is 0. For our this thing, let's get rid of that. All right. Now, with the advantage with such a function is you can call the function without any parameters as well, without any arguments as well. So when you call it this way, you see it says failed because marks is 0, because the default values are 0. Okay. Now let us say we do not have default arguments for M1 and M2. But there is default arguments for M3. In this case, you can pass 10, 20 and still the function will work. And still fail because the marks is 30. Any questions?
Okay.
Now,
I think that
one
answered.
thing to remember. Sorry, yes.
Oh, I think that answered my question. Thank you.
Yes, no problem. Now, one caveat here is if you want to have some positional parameters and some default parameters or default arguments for parameters, then the default argumented parameters must be passed after the positional parameters, which means if you write M3 equal to 0, if you pass in that value first, then this will throw an error saying non-default argument follows the default arguments, which means these are the non-default arguments, right? They should follow this. Yeah. I hope you understand what I'm trying to say here, right? Right. Which means The default arguments must follow the non-default, the default parameters must follow the non-default parameters. Which means this is the order in which it has to be there. And then it is accepted. Okay. Now, similarly, if you want to pass in a keyword argument in your function call, then you cannot say m1 equal to 10 and leave these two empty and this this thing. Again, the what do you call positional argument must precede the keyword argument. Which means positional argument is followed by keyword argument. Getting it? Now, when we do got multiple values for m1. Here in this case, you have to mention because you don't have default arguments here. Let us say m2 equal to 0 and m1 equal to 0. Now, when you pass this, m20 is not defined, of course. Yes. Now, when you pass this, it executes. So when you are passing arguments, and when you are passing arguments by using the parameters, param names, then order is not necessary. If you are not using the param names, then order is necessary. Any questions?
No.
All right. Which means we have covered positional parameters and arguments, default arguments, and keyword arguments. Now, coming to variable positional arguments. Let us try and understand this part now. So while defining the function, what I will do is I will write star params. Okay. Now, depending on the number of values I pass in, what I will do is for I will have my initial marks as 0. For I in params, I will say marks plus equal to I, which means I don't know the number of arguments that I'm going to pass to this function. Okay, when I don't know the number of arguments I'm going to pass to this function, I will write it as star params. In better way, we can write it as star args, which means I'm telling computer that I don't know the number of arguments I will pass. Okay. Now here what I'm doing is from the args, the variable number of args that I'm passing, take one value at a time and add it to marks. That is the only thing that this code is telling. And then once it comes out of this loop, we have the marks values defined in it, which means if we are passing 10 and 30 here, the first time the value in I will be 10, and since marks is 0, we are saying marks is equal to marks plus 10. Now marks will be 10, and in the second iteration, the value of marks I is 30, right? And then it is doing marks is equal to marks plus 10, marks plus 30, which is 10 is already there in marks, and now it is getting summed with 30, which means the resultant, final resultant is 40. And hence, when you run this code, it should print second class. Getting it?
Um, so can you repeat again? Like you said, like 10 and 30 is going into the arguments, right? And
Right.
and then the first, where will the 10 will go?
10 will go here, right? In I. For I in 10, which means for each value in args.
So I in 10. Okay, so it will step for like 10 times.
Not 10 times. Okay, for I in args, the first time, see, it has two values, right? Args has two values in it.
Correct.
And the first value is 10.
10, right?
Right? So in the first iteration, I will get the value 10 into it.
Oh, sorry. Okay, so I in 10 means that I value will get the 10 number. Okay, got it. Yeah.
Right. I in args.
Okay.
It's not I in 10. It's I in args.
Yeah.
Yeah. So in the args, the first value is given, I mean, is taken by I, and that value is being added to marks. And then it loops again. In the second iteration, the second value, 30, is taken by I, and that is summed to marks. Now, if we give here 40, what do you think will be the output? I mean, what will be the sum of marks after these iterations, after this loop?
So it will be 80, right?
Right. 10 plus 30 plus 40, resulting in?
Basically, when you put like for I in args, it's basically it rates into number of arguments that you pass. So if you have
Yeah,
three arguments,
it rates into.
it will iterate 3 times.
Yes, if you have 3 arguments, it will iterate 3 times. If you have n arguments, it will iterate n times.
Okay.
Right. Any further questions on this? We will leave the variable keyword arguments part for now, and we will learn about it when the time's right. Okay. Even with this, we are not still done with functions. Now comes the special capabilities of functions in Python. Okay. Functions in Python are called as first class objects or first class citizens. Now, what are first class citizens? Values and variables are called as first class citizens. Why so? They are called as first class citizens or first class objects because they satisfy 3 rules. What are the 3 rules for being satisfied? For becoming a first class citizen. Okay. The object, citizen or object, the object in question must be assignable to a variable. Okay. Object in question must be assignable to a variable. Object in question must be passable to a function, and object in question must be returnable by a function. If any object in a programming language is able to satisfy these three conditions, then those objects can be called as first class objects or first class citizens. Any questions with that?
Variable must be possible. Okay.
All right. Now let us take the first part. The object in question is a function. We should be able to assign this function to a variable. Then we can call it, okay, then we can say that it is satisfying one condition, right? Now, my variable name now is get marks alias is equal to get marks. Observe my syntax here. This is a defined function already. This function is already existing in the memory, in the RAM. Okay. But when I am assigning this function to a variable, I am not using the parenthesis. Okay. Observe that. Now what we will do is, let us bring this here, uncomment this. And instead of calling this function by this name, I will call by this alias. Okay. If I'm able to get this result, then will you agree that this function has been assigned to this variable? Hello?
You mean the result?
This is the
Okay.
original function. Yes.
So when that function is executed, it will receive a value that is assigned to the result. Correct? Is that question?
Yes.
Okay.
But the question is not that.
Hmm.
We have defined a get marks function, right?
Yes.
Here, we have assigned this function to a variable. This is simple variable assignment, right? Assignment operation.
Correct.
Now here, I am using the function name and I am trying to assign it to a variable. Now, when I call this variable with these arguments, this should result whatever this will return, right? Because this is just an alias to this function.
Correct. Yeah.
We are making the alias here in that line. Satisfied?
Yes.
So whatever result this is going to return, if this line is also going to return the same result, then that means that this variable is able to work with this function, which means we are able to assign this function to a variable.
Yeah. Or in other words, that it's basically inheriting all the things that get marks function has.
Let's not use the word inheritance here.
Okay. Yeah.
Yeah. It is just a simple assignment.
Okay.
Okay. You are assigning a function to a variable.
Changing a name. That's it.
Yes. Changing a name. Shall we run it?
Yes.
Are we getting the result?
Yeah. Yeah, it's all together is 80 and it's greater than or equal to 80. It's distinction.
Yes. Okay. Right. So, which means the first condition has been satisfied. Now, we want to make sure we are able to pass this function, right? what we will do is, let us get rid of this thing. We all know that print is a built-in function. At the end of the day, print is a function, right? Now, what we want to test here is being able to pass a function to another function as an argument. Okay. Any questions there? Now, this is a function, right? I will pass the function directly to the print function. Now, if this is printing a result, this means that I am able to pass this argument, this function as an argument to the print function. Am I correct? Excuse me. Hello?
Yeah. Yes, Gautam.
Again, we got the result. Okay.
Yep.
This is also done. Now, the third one, proving the third one is not as simple. It is simple, but we'll take a interesting use case for that. So I want to create a function that returns both quotient and remainder of two numbers. Okay. Of the division of two numbers, or okay, that is my problem statements. Is any questions in the problem statement? Now, for this purpose, what I will do is I will create a function called as define co and rem. Okay. This will take numerator and denominator. Okay. What this will do is this will return numerator divided by denominator, and this will return the quotient. But let's not simply do that. Let's define two more functions. Define division, and this takes numerator by denominator, and this returns numerator divided by denominator. And define remainder, again numerator comma denominator, and this will return this thing then. Okay. Now you guys agree that these two are two functions, right? Or do you not?
Sorry, can you ask again?
This is a function, right? Division
Yes.
is a function that we have defined, and this is also another function that we have defined.
Okay.
Right. Now what we will do is here I will say division of numerator comma denominator comma remainder of numerator comma denominator. Okay. Which means this is a function that is returning functions. Correct?
Yes.
Now, if this works, then we can say that functions are returnable by another function. The division function and remainder function are being returned by the co-rem function.
Okay. So I think at one point you actually replace the print to return, right?
Yes.
So here the return could be replaced with print, or is
Yeah,
the,
we can. Okay, okay, it can be replaced, but I guess you are getting a little confused. So what does the return keyword do is, let us say we are calling the function here, right?
okay?
Uh, print of quorum of, let us say, 100
Mm.
by 6, 100 comma 6.
Mhm.
Okay. What is the return keyword doing is, it is passing these values back to here.
Okay, okay, got it.
But what is print doing is, whatever we are passing to it, to the print function as an argument, it is sending it to the console
Okay,
or the standard output.
right.
All right. So when we run this function, it should print both the result of this and the result of this. Correct? Only then we can say that a functions can return functions also, satisfying the third argument.
Okay. So the order of execution of the code here is whenever it sees the definition, it's just the definition. So it will just, will it execute those lines or it will directly go to the place
It,
where
it, it, okay. Anytime a definition can never be executed, it is just stay in the memory.
memory, right? Okay.
Only when you call the function, they get executed.
Okay. So it will go through it, but all those things, everything will be in the memory. And then when we call the
Yes,
function, then it will start going back and executing. Okay.
right. So just in this case, we have commented this line, right? Now nothing will be printed, nothing executes.
Mhm.
But when we uncomment this line, there is a function call here,
Mhm.
which means these two values are going to these two parameters, or these two arguments are going to these two parameters.
And
And
then,
again, in turn, these two arguments are being sent to these two functions.
okay.
And the division function is doing the operation and returning the value to here. And this remainder function is making the operation and returning the value here. And this return keyword is returning both the values to here.
Okay. So the when you're calling the division and the reminder inside, those nem.den, does it need to be the same or it can be changed? Or it should, if I want to use
Okay,
it.
whatever names you are mentioning here, those should be the names that you mention here. For example, uh, if it is numerator, then that is the value that you can pass here, because this is the variable defined in this scope.
And okay, that's why it was showing like yellow underline because we did not call
Yes.
anywhere else.
Yes.
And then this one is saying it's not initialized or assigned anywhere.
Yes. Yes. Undefined variable.
Okay. But then the
But
name,
here,
okay, go ahead, yeah.
yes. Yes.
There,
Here in parameters, they are defined as this, and hence you can use the same this thing here,
okay, okay.
which means the value referred by numerator will be assigned
To the num.
to the num
Got it.
here, denominator to den. So whatever the parameter names are, those parameter names only you can refer to in the function, in that
In the,
function.
okay.
Since these are the parameter names, those you can refer to here.
Yeah. But then when we defining the other function, we could change those things. Because
Yes, we can
you're
change
passing
them.
it, you can reassign them. Okay,
Yes.
nice.
So since we have got to that, what we will do is let us understand how these two variables are, how Python is able to identify that these two are different from these two variables, right? Because this num and this done will be stored in the memory as division.num and division.den. And here this as just like our surnames. There may be many Gautams in the world, but one can identify me with my last name, right? So the function is the last name for this first name. Here, what to change? We can have this as NND. No, what we will do is num and then itself. But let us print them separately also to avoid any confusion with the scoping of variables. And here for definition, I will say 10 comma 20 and division, I mean. Here I will say for remainder 20 comma 30. Which means with respect to this function, for the function called as remainder, which means remainder.num is 20 and remainder.den is 30. Whereas division.num is 10, division.den is 20 with respect to these two function calls. Any questions there? Hello?
Yeah, nothing.
All right. Now it's
Um,
official. We can say yes.
so now if I want to print there, we can also print within brackets reminder.num, right? In let's say in the,
Reminder where,
so if I want to use that one reminder.num,
I mean, you want to use outside this value, outside of this function you are saying?
I don't know whether I think it won't work right outside of the function, but you can inside
Inside
the
of the function, you don't have to say reminder.num.
yeah, exactly. Oh yeah, outside of the thing. Yeah. Will it work outside of the function?
What do you think?
Because you are calling that function and then also asking what is the number, so it should work because you are telling it to in the right way, right?
But still, it is okay. The scope of this variable only is for within this function.
Okay. Okay.
Outside of the function, it cannot exist.
So then what is the use of that? The reminder.num?
Okay. Okay. Python remembers it this way. It doesn't get confused between this num and this num.
Okay, okay, okay. You're saying okay, that's how it recognizes.
In the memory, see, at the end of the day, both variables are num and den, right? So how do you think Python clearly knows which num are we referring to when we are saying num here?
Right, right.
Here also we are saying num and den. Here also we are saying num and den.
Mhm.
For in the memory, in Python's memory, both are num and den.
Right.
But how can it identify each individual's num and den? It does by using the function name as the, what do you call, last name.
Last name, yeah. I mean, I saw a lot of people writing code with similar type of pattern, reminder.num.
We will show that. We will look into that. That is possible. That way is possible when we write classes in Python.
Got it. Because it
And
comes.
here, these are just functions.
Okay.
Okay.
Thank you.
No problem. Any questions? Anybody? Now we can officially say we have finished user-defined functions. We have too much to cover tomorrow in that case. So we may not be able to do unit testing tomorrow, but that's okay. If we learn just constructs of Python, then we should be more than enough. I mean,
What is unit
that should
testing?
help us enough.
It's just like a
You
practical.
write program and you want your programs to be tested automatically, right? You don't want to run them again and again and check. I mean, print the values out and then check if your function is working correct or not. You want to automate your the code that automate the tests that you want to put your code through.
Okay. Interesting.
Right. So for that, it's a way to automate code testing.
Okay.
But that's not this thing, not a mandatory topic, but we'll see.
Gautam, can you share
Okay.
that script, what you have, the long script, so that we can able to practice it?
Sure, I'll put it in the drive, the common space. Okay, I remember I have created a drive and shared it with you all. Did you guys receive it?
Drive, yes.
Constructs of Python and this bootcamp.
Yeah, I saw only one document there. Yes. Yeah.
Right. So you guys can start downloading it and practicing the problem statements here. You can do with variables, operators, conditional statements, loops, string manipulations we'll do tomorrow. And yeah, you can do until then today. And then we can take care of the rest tomorrow.
Will you be able to share your
Okay.
script also, just in case, for reference?
Yeah, sure. I'll put mine too.
Okay, thank you.
Yes, no problem.
Yeah, take rest, Gautam. Thank you so much.
Thank
No
you.
problem. Let me stop stream sharing and no problem. Thank you all. Yeah, let's disperse for the day. Thank you. Bye-bye.
Thank you. Thanks again. Thank you. Thank you.